There is a reason I'm wearing the same shirt, and that is, at this point, I'd normally kind of do a little introduction about who I am and what I do. I'm not going to bother with that. Instead, I just want to recreate this photo. If somebody over there could take this photo. Thank you. This is fundamentally all about me. It's nothing to do with you, so thank you. So I'm Sam. I want my real name on Twitter, and you can get the code for what I'm going to talk about today on my GitHub, where there'll be a bigger URL at the end. So I'm going to talk about Codeable. It's new in Swift 4, and the reason for it is all to do with serialization. What exactly is serialization? So the beginning of any talk involves a quote from Wikipedia, which tells you what serialization is. We all know what serialization is, but this is what Wikipedia says. So it's all about taking the data structures inside your app and then either storing them on disk or passing them to somebody else, and then at the other end being able to reconstitute those data structures inside your app. One of the most popular ways currently, the most fashionable way to do data serialization is via JSON, which looks a little bit something like this. So this is an extract of an API that I made last week. So it's a very kind of, you've all seen JSON before, I'm sure. That's what JSON looks like. And the challenge is to turn it into something that looks a bit like this. So I've got a Swift struct with various properties inside it, and I want to be able to extract them from the JSON. So how would I go about that? Well, if we were using a dynamic language, which Swift is not, there's a couple of different ways you can do it. One of which is you can completely construct your model objects at runtime. Now, this isn't necessarily a good thing to do, but effectively what you do is you take your JSON and you see, well, I've got a property called name. So when I make my object, it's a dynamic language. I can make what the hell I like at runtime on that object. I'm going to make a property and call it name, and I'm going to populate it from the JSON. You use the JSON to completely define at runtime what goes into your object model. It's not a very good thing to do. In Ruby, you would do it like that. Really simple JSON parsing in Ruby. OpenStruct is a special class type. It's effectively a thing that makes a hash, a dictionary, look like an object. But you can do that in Ruby, a dynamic language. An alternative inside dynamic languages is to use introspection or reflection, where effectively you say, well, I've got this model object, I've got these properties on it, can I find them in the JSON? And I'll show that in a bit more detail in a moment once I move on to static languages. Static languages, like Swift, you can't do the randomly make an object up out of whatever you find in the JSON at runtime, because you need at compile time to know what that object's going to look like, pretty much. Once again, you can use introspection, which is why I didn't really explain it in any great detail. So introspection, reflection, is you take a look at your object, you see what attributes, what properties it has on it, and then you go searching through your serialized string and see if you can find that data in there. So in C#, if you're using, there's a library called JSON.NET, you can do something like this. So I've made a product model somewhere, and I'm going to make a product out of this JSON string. So there's a JSON convert deserialized object that is, I've forgotten the word. Oh. Sorry? Generic, thank you. That is, as before, there are two words in this talk that I can't remember. One of them is generic, which I forgot, despite the fact I sat there about 5 minutes ago going, I need to remember generic, and I need to remember the other one, which I've also forgotten. Look forward to that later. So I tell this function here, you're going to build a product. It then uses reflection to look at that product and find out what attributes there are on it, and then extracts them from the JSON string. And it will return you a product at the end, a product which is something you defined when you built it in the first place. You can't do that in Swift. Swift does have some element of introspection, some element of reflection through mirroring. However, you can't assign properties through reflection, which you can do in C#. So that isn't an option in Swift. So, what options do we have? Now, about 2.5 years ago, it was really fashionable to write blog posts about how to do JSON parsing. This is from my blog post 2 years ago about how to do JSON parsing in Swift. I presented 3 different options. This was the first one, which is naive parsing. So you can use NS-JSON serialization to turn, which is in Foundation, to turn your JSON object into a load of dictionaries and arrays. And then you can, I mean, I can barely read it, so the point is, there's a lot of code, and it's not doing very much. This is taking the GitHub API, it searches through the JSON, trying to convert various different things into the right types, and if it can, right at the end, in this little line here, it creates a repo object. So this could be rewritten. This is using, I guess, Swift 1.2 or something, so the code itself is irrelevant, but it's a mess. So there are various different approaches that you can use, third-party libraries, one of which was Swifty.json, which at the time seemed quite nice. We're coming up to the word that I can't remember. Then what you do with this is, it's kind of similar. It's just a nicer API around basically the same thing. So rather than having to attempt to cast each of the things that you pull out, it has some nice methods on the end that will pull out strings and bools and such like. And it uses subscripting, that's it. This here, so you can use subscripting to be able to find out whether or not you've got something at each level within that JSON. So it's a bit better, but it's still a mess. And then the third option that I looked at is a third-party library called Argo, which takes a functional programming approach. And as a bit of an aside here, I have a friend called Rich Turton who did a great talk called I'm an Idiot. It's all about how when you're writing code, then you need to write code that's easily understandable, and just showing off is not very helpful. Because then when you come back to it later, you have no idea what it does. He calls this, so when you write code that you can't really understand later, and you're just showing off, he calls it public masturbation. This here is public masturbation. I have no idea what that does. I wrote this 2.5 years ago. I don't know what any of these custom operators do. I have absolutely no idea what line this does. But the important thing is it's like about 20 lines, and it looks really cool. I wouldn't recommend using it, because I don't know how it works. But I'm sure at the time it made me feel really clever. I have no idea. Anyway, don't use that. So, that's the state of play before we got to Swift 4. Enter Codeable. New thing, Swift 4. What it does is you do something very simple, and then the compiler will generate stuff for you that then allows you to do JSON parsing. And not just JSON parsing. I'm concentrating on JSON parsing. You can do other things as well, include property lists. But the compiler does the work for you. And what it's kind of doing is the bit of reflection that you don't have, that you need, the compiler generates what you need to do your encoding and decoding, your serialization and deserialization. So how do you do it? Well, step 1 is you adapt this codable protocol, which we'll look at in a bit more detail later on. So whatever you've got an object, you've got a class, a struct, an enum, whatever you've got, you just adopt the codable protocol. And step 2 is you're probably done in many, many cases. That's all you need to do. It's like magic when you see it, and we'll look at it in a moment. In fact, we'll look at it now. Here's a demo. Can you still hear me? Good, right. So, I'm going to start off with a really simple example, which is just going to be to encode a property. So how do we do this kind of thing? Well, I'm going to create a string, and I'm going to call it, a string, str traditionally, my string, and I want to encode that somehow to JSON. Now, to do this, you need a couple of things. First of all, I need to create an encoder. And there is a concrete class called JSON encoder. I'm going to instantiate one of those. And then I can grab some JSON data, which is on the encoder. Oops, encoder. I'm going to call the encode method. And I put in the value that I want. So I'm going to put an array that contains just the letter string. And if that runs, then I've got a 13-byte chunk of data now out of there. And what does that look like? Well, we can see that with, if I do, let's create a string. Let's make it up for some bytes. The bytes is the JSON data that I had, and the encoding is UTF-8. If I do that, then you can see out of the end here, come on, there we go. Then it creates the JSON for encoding an array with a single string in it, my string. And that there that's it. That's all I had to do that. And pretty much the cool thing about this is, as we look at more and more advanced examples of what you want to encode, that doesn't really change. It's really quite cool. How would I go about decoding that back again? Well, this time I need to create a decoder, and it's going to be a JSON decoder, because, oh no, not a K-mark, because for code return. JSON decoder, it's one of them. And I'm going to create the decoder string, so I want to do I'm just glossing over the fact that I'm putting try exclamation marks in here. We'll just ignore them. Decode. Now, when you decode, you have to tell it, what do I expect the thing that I'm going to decode to turn into? What's the type of the stuff that I'm expecting to see inside my JSON? So in this case, I have an array that contains string. I want the type, so I'm going to use the self. .self, and in the data I just pass in the JSON data. And out of the end of there, it has created an array that contains my string. So I mean, none of this is particularly spectacular. I've taken my string, I've put it in an array, encoded it to JSON and pulled it back out again. So nothing particularly complicated. The important part is that we've got an encoder and we encode something, and then a decoder and we decode it. And it pretty much is that. So if we move on to see, well, what else can we do? So now I've got a dictionary that is of type string to int. I've created an encoder already. So once again, if I want to create the encoded version, then I do exactly the same again. I try and I take the encoder and I encode it's called dict. That creates data, and let's just check that that's created something we understand with bytes from encoded, and the encoding once again is UTF-8. What's that going to turn out? Oh, almost see it. Then that's created a JSON string that looks very much like a JSON object, right? We've gone from string, we've got to int on the other side, to number, I guess, in JSON on the other side. That is the JSON string that goes with it. And then decoding it again will be the same kind of thing. Remember that you have to provide the type. So the type here will be an array of strings to ints, not an array, a dictionary of strings to ints from the data, which is, what did I call it? Encoded? Encoded. There we go. And then out of the end of there, you can almost see, and I can't make it wider, I can't do anything with it. There we go. You can see it's a dictionary with the same values in it, with people going to 24, 6 cars and 18 cats, whatever that means. Okay, so again, this still isn't particularly exciting. Like, we can already do NSJSON. I've just dropped the muff, excuse me. Let's pop that back on. NSJSON serialization will let you do the same thing. This is nothing special here. But I mentioned that it's really easy to do your own stuff by adopting the Codeable protocol. So I've got a struct here called person. It's got 3 properties in it. It's got a name, age, and favorite color, string, int, and string. We'll gloss over the fact that color is a string for now. And all I have to do to make this accessible to JSON encoder is to adopt the Codeable protocol. And I don't have to do anything else. As long as all of the constituent properties, the constituent parts of the thing that you're making codable are themselves codable, which string and int are, then I don't have to do anything else. The compiler will now go away and generate the 3 things it needs to generate. There's an encode method, a decode method, and something called coding keys, which we'll look at later on. So here I've got Majuli, who I've created as a person. She's 43 and her favorite color is orange. She's a classy lady. And so then if I take, once again, it's the same code again. You might have thought that I could have copy-pasted this rather than you having to sit and watch me type it over and over again. But I'm just going to do the same thing again. Encoder, encode, and the value is Julie. And I want to do that string again so I can prove to you that it's doing something. So we pass the bytes in, which is JSON data. The encoding is still UTF-8. And out of the end of there, then it's created an object. So it's worked out somehow that a struct can be expressed inside JSON as an object with name, age, and favorite color as the keys. And how would I go about decoding that? Well, funnily enough, it's almost identical to everything else that we've done so far. You take the decoder, you call the decode method on it. The type this time is person, because I want to resaturate it as a person type, and the data is called JSON data. And you'll see right at the end of there, I have a person object that looks identical to the person object that I started with right at the beginning. So that there, to get that to work, this stuff here is all identical, and it's like 2 lines for each of the things you want to do. And I just added this codable, adopted this codable protocol and did nothing else. The compiler does it all for you. And that, I think, is quite cool. So given that it can do that, and I've already showed you that things like dictionaries are already codable, I can add other stuff to this. So say I want to add a property called relatives, which is going to be a dictionary which is string to string. Then the compiler's not complaining about this because it can tell that that itself is codable, doesn't have to do anything. It's complaining down here, so let's add relatives. We'll have a mum called, what should we call her? What did I call her before? Don't know. But we'll call her Jane. And a dad called, I don't know, Peter. They're lovely names, aren't they? So now that's no longer complaining. And if I now look at the output, you'll see that within that object for the person, for Julie, there's now a sub-object that contains the mum and dad, the relatives thing that we just created under the relatives key. That's quite cool, but why am I using a string here? That doesn't make a whole lot of sense. What I want to use instead for a relation, there are only a certain number of relations that you can have, I suppose, or types. I'm going to create a relation enum, which will have case mum and case dad. And then I can change this here from a string to a relation. This, then we lose that, we put a dot in, we do the same over here. Okay, so now I've switched it from being keyed on a string to being keyed on this enum. And now it's not happy because it can't synthesize where should we start? Let's start at the top here. It does not conform to protocol decodable. And why doesn't it conform to protocol decodable? Because this dictionary doesn't conform to decodable, which doesn't do that because relation doesn't conform to decodable. So let's add codable on here. Now it's still not happy. The reason it's not happy, we ignore the fix because that's useless. The reason it's not happy is because I've not told it what the associated type for that enum is. So now I've set that it's an int, then it's all happy. And if you look, where do we look? Where's my string? Here's my string. If we look here, you can see that now it's keyed on 0 and 1 because I said my enum was my enum was based on an int. The other interesting thing is that it has changed it from being an object to an array. And I have a couple of slides on that aren't particularly exciting, but let's have a look at them. So JSON, what exactly is JSON? And why is it using an array instead of using an object, which is what we'd expect it to? JSON is actually really simple. You may have seen diagrams like this in the past. Essentially, what you've got here is a value. So value appears in JSON all over the place. A value can be one of these things. It can be a string, a number, an object array, true, false, or null. And that's it. Now, I could go into what a string and a number is, but having seen the talk earlier, I don't know what a string is anymore. So we'll ignore those two. What is an array? Well, an array starts with a square bracket. It then has a value in it. Optionally, you can have a comma and then another value, and then a comma and another value, and then it ends with a square bracket. And then an object starts with a curly bracket, curly brace. It has a string, a colon, a value. Remember the value of those 8 things or something before. Optionally a comma, and then it goes round and round and round until you then put the closing curly brace. The important part of this is that the key has to be a string. So if you're creating a dictionary where the key is a string, that's fine. Swift will go ahead and use that. However, in this instance, when I'm using an enum as a key, particularly for an int, then it can't use an object there because an int isn't a string. So instead of using an object, it switches to being an even length array where the 0th and 0, 1, 2, 2th, second ones will be the keys, and then the odd ones will be the values. And just to show that actually this int isn't very useful, I mean, you're not often going to be sending JSON, well, maybe you are. I can switch that very easily to become a string, so it's then its associated type becomes a string, and then that will update, and oh god, no, don't go there. This one is the one I want to see. Now it's now using the strings that it generates for that enum. Notice it's still using an array, and I don't know why, because I've not looked at the source code. I suspect that every time there's an enum, it always does it this way, rather than deciding that an enum with a string should be a special case compared to all of the other things that you could use. Okay. Right, so I mentioned very briefly before that favorite color is a string and we should gloss over it. I don't think we should gloss over it anymore. Let's have a go at changing it to a color. And to do that, let's have a quick look at what Decodable is doing behind the scenes. Where are we? You go, you go. Right. So, this is the encodable protocol. It has one method on it, encode to encoder, encoder. So when you assign something as being encodable, which is, so codable is encodable and decodable, then what it's doing is the compiler will generate this method for you. It's a method that something will call, it'll pass it an encoder, and then the object itself will be responsible for encoding itself within the object. What's an encoder then? So I've got this is another protocol, it's an encoder protocol, and within there we have three methods. There's a couple of extra things in there that I've ignored. Three methods that return containers. A container, a keyed container, an unkeyed container, and a single value container. What the hell does that lot mean? I think I've got a diagram. Right, here we go. So JSON encoder has an encode method on it that takes an encodable. An encodable has an encode to encoder method, and then the encoder itself has these three things on it. A container keyed by is a keyed container, that's an object. So I'm saying that I want to encode myself as an object. Or I could use the unkeyed container, so I want to encode myself as an array. Or finally, I want to encode myself as a single value, either a string number, a boolean, or a null. So your responsibility as the object that will be encoded is to work out how best should I encode myself. And I'll show an example of that. The decodable protocol is almost exactly the opposite. This time it has an initializer that takes a decoder and says, go resaturate yourself from this decoder. The decoder itself, you can ask for one of these three containers, and then from each of those containers you can extract the values that you need to populate yourself. So that's all a bit abstract. Let's have a go at that. So we've got the same person thing again. This time we've switched favorite color to be a UI color because we fancy a challenge. Why shouldn't we be able to encode a UI color so then at the other end we can then decode from a UI color? Why shouldn't we indeed? So I've got an extension of UI color and I'm going to make this conform to encodable.
Sorry, I'm having trouble with the connection.
Cheers,
Please try again in a moment.
Thank you. What do we have inside the encodable thing? Is this going to... No, it can't automatically do it, so I need to write it myself. I need to write the encode method. That's the only thing that's in there. How do I encode a UI color? Well, I get given an encoder, so I'm going to create myself a container. And that comes from the encoder. I want a container, an unkeyed container. So I've decided I'm going to take my UI color, and in a really simplistic model, I'm going to extract the red, the green, the blue, and the alpha component and chuck them in an array. So I want an unkeyed container, i.e. an array. I then want to faff around a bit and get the color, so bear with me while I type out quite a lot of guff. I'm going to CG float, CG float. Yep, so I want a red component, I want a green component, I want a blue component, and I want an alpha component, CG float. And the reason that you have to do this is because of the method I don't like that's inside UI color to extract the value of the color. I'm sure there's a great reason for it, but it's this weird backwards thing where you do get red, and I have to give it a pointer to the red that it's going to populate. It's like we're back in the land of C. So I want a color, I want to put the red in the red component, I want to put the green in the green component, I want to put the blue in the blue component, dot blue, and the alpha goes in the alpha component. So all I've done there is I've populated this color variable with the 4 components that I want. Then I can encode each of those in order inside my container. So I've got a container, I'm going to say encode, and the value that I want to encode is color.r for red. And I repeat that. The order obviously matters here because it's unkeyed. So, well, the key is the index, I guess. So G, then B, then alpha. What's wrong with you? No, you are used. Good. Now it's no longer complaining that it's not encodable because now UI color is encodable because of what we've got here. And if we now look at the string, why have I not written that out already? String, same stuff again. The bytes is JSON data. And the string encoding is UTF-8. And if we take a look at that, you'll see that now the favorite color is represented by an array of 4 numbers, which are particularly nicely chosen to fit on the screen. And so in theory, I can then take those 4 colors. The first component is red, then green, then blue, then alpha, and I can resaturate that back at the other end as I would want to. Now, that's an unkeyed container, right? That's just chucking them in an array. But that requires me to know the order of those keys and components. What if I don't know? Then it would make more sense here to use a keyed container. So how do I do that? Well, first of all, I need to create the keys. So create an enum for keys called color keys. Color keys. And that is a dot coding key. And I just want to put some cases in there. We have red, but not that method. There we go. Case green. Case blue. Case alpha. And instead of getting the unkeyed container, I instead grab the container. Coding key protocol is color keys. Color, is it there? Is that it? Yes. .self. So here you pass in that I want to create a container that has these keys on it. And then here, this doesn't work anymore. I need to specify the key that each one is going in. So I go for key, and then I would put red. And then I'm going to copy and paste this, because then we have green, then we have blue, then we have alpha. So we have red, green, we have blue, and we have alpha. I'm acutely aware that I haven't got much time left. I'm going to carry on. Now what does this look like? Then instead of being an array, it's now an object keyed on those values that I put in. It's not in order, but objects aren't in order. So we've got the red, the alpha, the blue, and the green. So it's a little bit easier to understand. So there we go. We've managed to take UI color and turn it into JSON. That's great, right? So all we need to do now is go in the opposite direction and decode JSON into UI color. Spoiler alert, you can't. Let's see why, or let's attempt to see why. So the first thing we might want to do is let's make an extension on UI color. Not on UI view, UI color. And we'll make it a .decodable. What method do we have on there? We have we have init from decoder, I think is the method. Initializer requirement can only be satisfied by required, so okay, so we need to add public, and we need to add required. Happy with that? No. What's wrong now? Oh, no, convenience. Oh, for goodness sake. Convenience. Anything else you want? What's wrong now? Right. Required initializer must be declared directly in class UI color, not in an extension. So I can't do it using an extension. What I could do then, given that I'm not allowed to do that, is, well, how about if I create a subclass of UI color, and then I can declare all the initializers that I want. I've run out of time, so I'm not actually going to do that, but I'll tell you now you can't. You can't because you can't override that there is an initializer that's declared in an extension on UI color that you can't override in a subclass. So there's no way that you can possibly do it. I've got a link later on to a thing on the Swift mailing list that explains why you can't do it far better than I would ever be able to. But essentially what's happening here is you can't do this. And you can't do this because it needs to be an initializer. What could we do to get around that? Well, if I show you embedding color, this one here. So instead of actually trying to subclass UI color, or instead of trying to make UI color itself codable, I can create a struct called color, which has red, green, blue alpha components, and then I can initialize it from a UI color. I can create a UI color from it, and that in itself I can make codable just by writing codable on the end of it. Now this is happy that it's codable. I can no longer use that directly. I've got to create a color from a UI color, from a color literal. What color should we have? Let's have that rather pleasant red. And then right down, I can now decode as well as encode. And if I go down at the bottom and go decoded dot favorite color. Oh no, not you. I thought what have I done wrong? What's going on? Decoded up. Thank you. Favorite color dot UI color. I will be very quick, honest. I won't. Then down at the bottom, that color has now been resaturated from the UI color that we had at the beginning. Okay. The one thing that I will show you one more demo, and I don't think I have any more slides, so let's have a quick look at this final demo, which is, I like to think, is a little bit more realistic on what you're likely to want to do with Codeable. And that is, I've got some JSON from an API that looks a little bit like this. It's got a load of stuff in there, ID, name, price, product group. It's got this important thing here called cover URL, and it's got something called relative URL. Just remember those for a moment. So I've got inside my decoding page here, I've got a product here. It doesn't have those properties. It has one called image URL and one called URL. How would I go about coding this? I think I'm just going to show you the answer rather than discard all that crap. Go away. Let's have a look at here. Right, here we go. So we don't get syntax highlighting anymore. It was nice while it lasted. Lovely. So what I've got here then is the same stuff you've seen before. I'm grabbing the JSON data from the contents of that URL. I've made a decoder. I'm decoding it. I've got an array of products, and I'm getting it from that JSON data. And I'm printing the products. The important part here, syntax highlighting at the top of the page. Lovely. The important part here is I don't want to use image URL. I don't want to use, cover URL and relative URL. I want to use image URL and URL. And I can do that by one of the things that the Swift compiler generates is this coding keys thing. I can create my own, and that allows me to specify that image URL is actually called cover URL, and URL is relative URL. So this is one of the three things that the Swift compiler generates that I'm going to generate instead, and I can override the name of the keys. Really quite easy to do. It just is an enum that takes a type string, and it has to adopt the coding key protocol. So I think that's quite a useful thing. And with that, I shall walk over here. Right. So, in conclusion, unlike a lot of iOS 11 stuff, so I spend quite a lot of my time talking about, look at the great new things that you can't use. Because in reality, nobody has an app that is iOS 11 only. So I could have come up here and talked about drag and drop, or I could have talked about ARKit, and we could all look at it and go, yeah, that's amazing, and then everybody would go home and not be able to use it for a year and a half. However, unlike the stuff in iOS 11, you can use this now, which is great. And that's because it's a feature of Swift, not a feature of iOS 11. I say that once you've migrated to Swift 4. So you do have to do something, but I think this is a much more... this is something that you can do and it won't affect users, whereas saying iOS 11 only is something that would affect users. I really like it. I think it's... You saw the crap that I wrote 2.5 years ago for the blog post. I would never want to write anything like that. I think this is really nice, it's really powerful, and I think you should have a try with it. I mentioned that there are various links. I'll put these slides online. The first two are by Greg Heo, who spoke to us earlier, are really good at explaining how does this work under the covers. It uses NS-JSON serialization. How does that actually work? What's going on? Which things talk to which? All that kind of stuff. Then there's a couple by Mike Ash, which explain, A, first of all, how do you do it? And then B, how do you create your own encoder? So he creates a binary encoder as opposed to a JSON encoder. And then right at the bottom here is a link to the Swift Evolution mailing list that explains why you can't add decodable conformance to other people's classes. And with that, I'm done. You can get all of the code at this URL at the top, and you can send me hate mail on Twitter. Thank you ever so much. I guess we don't have any time for questions, so come and bug me later. I'll be happy to talk to you.
Yeah, so thanks. Let's thank Sam again for that wonderful talk.